Hi there, Mr. Holcomb here with another episode of The Math Behind the Modules. This is Lesson 1, Module 6, Modeling Linear Relationships. Example 1 says logging on. Lenora has just purchased a tablet computer, and she is considering purchasing an internet access plan so that she can connect to the internet wirelessly from virtually anywhere in the world. One company offers an internet access plan so that when a person connects to the company's wireless network, the person is charged a fixed access fee for connecting plus an amount for the number of minutes connected based upon a constant usage rate in dollars per minute. Okay, so they're being charged a fixed access fee plus an amount for the number of minutes connected based upon constant usage. So the key there is constant usage rate. Okay, so that means that it is a constant rate of change, is linear, and in dollars per minute. Okay, so Lenora is considering this company's plan, but the company's advertisement does not state how much the fixed access fee for connecting is, nor does it state the usage rate. However, the company's website says that a 10-minute session costs 40 cents, a 20-minute session costs 70, and a 30-minute session costs $1. Lenora decides to use these pieces of information to determine both the fixed access fee for connecting and the usage rate. Okay, so exercise 1 through 6. Number 1 says Lenora makes a table of the information and a graph where number of minutes is represented by the horizontal axis, time, that's x, and the total session cost is represented by the vertical axis, y. Plot the 3 given points on the graph. These 3 points appear to lie on a line. What information about the access plan suggests that the correct model is indeed a linear relationship? Okay, so it says to plot these points. So I'm going to plot the point 10, point 40. So 10 is here, point 4 is probably right about here. Okay. Point 2 is 0.7, 0.7 is probably right around here, 0.5 would be here, 0.6, 0.7, 0.8, 0.9, okay, and so forth. Actually, 0.7 might be a little bit lower, so maybe it's less than 7.5 would be halfway, so 0.7 would probably be more like there. Okay, and then 30 is exactly 1, so that's right there. So that does appear to be linear. It says these 3 points do appear to be on a line. What information about the access plan suggests that the correct model is indeed a linear relationship? Okay, so what I need to do is, if there's going to be a constant change, then if I find a rate of change, that'd be, if this was y2 and this is y1, and this is my x2, and this is my x1, and I find the rate of change, which is change in y over change in x, well, that's 70 minus 40, which is 30, over 20 minus 10, which is 10, and that is a difference of 3. Okay, so for every 10, it's changing 30 cents. For every 100, it would be changing, let's see if I got that right, 0.30, I'm sorry, 0.30, so it'll be 0.3 or 3/10. So 30 cents per 10 minutes is what's changing. So here's 10 minutes, 40 cents. Here's 10 more minutes, add 30, 70 cents. 10 more minutes, add 30 cents, $1. So there is a constant change from here to here of 30 cents. There's a constant change here of 30 cents. Okay, so that is the reason. So the amount of change for the minutes connected is based upon a constant usage rate in dollars per minute, and that is 0.3, 30 cents per 10 minutes, or 3 cents per minute. Number 2, the rate of change describes how the total cost changes with respect to time. A, when the number of minutes increased by 10, example from 10 to 20 minutes, or from 20 minutes to 30 minutes, how much does the change increase? And the change increased by 30 cents. B says another way to say this would be the usage charge per 10 minutes of use. So that information, use that information to determine the increase in cost based on only 1 minute of additional usage. In other words, find the usage charge per minute. Okay, so if I am using 30 cents for every 10 minutes, and I divide by 10, then that is going to move the decimal one place to the left, and that is going to equal 0.03. So 0.3 divided by 10 is 0.03. So that is going to be 3 cents per minute. Number 3 says the company's pricing plan states that the usage rate is a constant for any number of minutes connected to the internet. In other words, the increase of cost for 10 more minutes of use, the value that you calculated in exercise 2, is the same whether you increase from 20 to 30 or from 30 to 40 and so on. Using this information, determine the total cost for 40 minutes, 50, and 60 minutes of use. Record those values in the table and plot the corresponding points on the graph in exercise 1. So what they're asking us to do now is 40, 50, and 60 minutes of use, substitute in our values and graph. So I'll go back, and now we want to fill this in here. And I'll do that in green. So if this is increasing 30 cents every 10 minutes or 3 cents every minute, this is an increase in 10 minutes, so this will be an increase in 30 cents, so that's $1.30. This is 10 more minutes, so this is 30 more cents. This is 10 more minutes, so this will cost 30 more cents. So it's $1.30, $1.60, and $1.90. So at 40, we're at $1.30, which is a little more than $1.25, or right here. At 50, we're at $1.50 plus another 10 cents, which is maybe right about here. And then finally at 60, we're up at $1.90, which is approaching $2. So it's still looking pretty linear here with respect to those first 3 points we graphed. Number 4 says, using the table and the graph in exercise 1, compute the hypothetical cost for 0 minutes of use. What does that value represent in the context of the values that Lenora is trying to figure out? So if we go back to this table, they're saying hypothetically how much would it cost back here? Well, if we're adding 30 cents as we go up, then we're subtracting 30 cents as we go backwards. So this would be 40 minus 30, or 10 cents. So the total session costs 10 cents for 0 minutes. Okay, so 10 cents for 0 minutes means, okay, 10 cents for 0 minutes represents let's see, let me go back to the original and I'll underline what it says. A fixed access fee. So that's what they're calling it, an access fee. So I just wanted to use the right terminology here. So that 1 cent for, or I have 0.1 for minutes represented. That is not right. This is 10 cents for 0 minutes represents the connection fee. Okay, number 5, it says on the graph in exercise 1, draw a line through the points representing 0 to 60 minutes of use under this company's plan. The slope of this line is equal to the rate of change, which in this case is the usage rate. So they want us to draw a line through all these points. So if I bring this down to this first point here, rotate this up, okay, and there is the equation. Now I don't want to go past 0 here, of course, because you can't have negative minutes, and you aren't going to have, they aren't going to pay you to not sign up. So there's no such thing as negative dollars fee. Okay, this did not go through the origin, but it wasn't supposed to, because at 0 it's supposed to be 10 cents. So there's about 10 cents. That is the initial connection fee, and then 30 cents per minute after that. Number 6, using X for the number of minutes and Y for the total cost in dollars, write a function to model the linear relationship between minutes of use and the total cost. So Y equals mx plus b is our equation. M is our slope in linear equations, but we are calling slope here the usage rate or the constant rate because it is constant. And we know that it's 30 cents per minute. So my equation is going to be y equals 0.30x plus, and my y-intercept is b. That's my initial cost when I connect, and that is my 10-cent connection fee. So the equation is y equals 0.3x plus 0.10 in terms of dollars. Example 2. Another rate plan. A second wireless access company has a similar method for computing its costs. Unlike the first company that Lenora was considering, the second company explicitly states its access fee is 15 cents. That is our B. And its usage rate is 4 cents per minute. That is our M. Total session cost 15 cents plus 0.4 number of minutes. Exercise 7 through 16 says, number 7, let X represent the number of minutes. Okay, so that's putting the X in place of that word number of minutes there. Used, and Y represents total cost in dollars. Total session cost is Y. Construct a linear function that models the total session cost based on the number of minutes used. So all we're doing is taking Y equals our slope. In this case, slope is being called constant rate, okay? And therefore it's y equals mx plus b, where y is our total cost. Our number of per minute, that's the one that we're multiplying by, that's our slope, 4 cents per minute, 0.4x plus 15 cents to sign up or connect, and that's 0.15. So y equals 0.4x plus 0.15. 8 says, using the linear function constructed in exercise 7, determine the total session cost for the sessions in the table 0 through 60 and fill in any values below. Well, if I plug 0 in here, which is 0.4 times 0 is 0 plus 15 cents, it's going to cost 15 cents. Multiply 0.04 times 10, and that's going to be 40 cents. 40 cents plus 15 cents is 55 cents. Substituting in 20, I'm going to get 0.04 times 20, which is 0.8. 0.8 plus 0.15, or 80 cents plus 15 cents, is 95 cents. So I'm going to stop calculating right there because these are going up by 10, 10, 10, 10, 10. So it's the same multiple every time. And if you notice, we're increasing by 40 every time. So 95 plus 40 is $1.35. $1.35 plus 40 is $1.75. $1.75 plus 40 is $2.05. There's a 2.15. 2.15. 2.15 plus 40 cents is 2.55. Okay, number 9 says, plot these points on the original graph in exercise 1 and draw a line through these points. In what ways does the line that represents this second company's access plan differ from the line that represents the first company's access plan? So I have copied this table over, and I'm going to go back 2 pages to the first page where we're supposed to put this in. And I just copied it here so I can read it without going back and forth and back. Anyhow, so 0.15 cents is going to be a little bit higher, which is right about here maybe. Or maybe even closer probably, because that's only a difference of 5 cents, and this distance is 50. Between 0 and here is 50. So how about right there? So there's 15 cents. 55 cents after 10 minutes is 50 plus a nickel, which is just a little bit over, say here. And then 20 is 95, just shy of $1, which is right here. And 30 is $1.35. Here's 25 and maybe a little bit more. And 40 is $1.75, which is halfway between 150 and 2. And 2.15 at 50, I go up 2 and 15 cents, might be about here. And then finally 60 and $2.55 is about there. So if I bring my ruler over here and line it up, okay, since I just adjusted my ruler like you saw, I tilted it so it went up steeper. Okay, that means that it is a steeper slope. That means that it is a greater rate of change. And it is, because this is a difference of 30 cents every 10, and this is a difference of 40 cents every 10. So there are the two equations. So this is the second company, and this is the first company. Okay? So there they are graphed. Go back to the question here, and it says, in which ways does the line that represents the second companies differ from the line that represents the first plan? Well, the second company charges more to connect. Okay, the y-intercept was higher, and the second company charges more per minute for service. Okay, next page. MP3, where was I? I had it. Hit something. Okay, MP3 download sites are a popular forum for selling music. Different sites offer pricing that depends on whether or not you want to purchase an entire album or individual songs a la carte. One site offers MP3 downloads of individual songs with the following price structure: a $3 fixed fee for a monthly subscription plus 25 cents per song. That's pretty cheap. Number 10, using X for the number of songs downloaded and Y for the total monthly cost in dollars, construct a linear function to model the relationship between the number of songs downloaded and the total monthly cost. So we're going to do an equation of Y equals mx plus b, and we're going to substitute in. M is our rate of change, that's per song, 25 cents, so it's 0.25, where X is number of songs, plus there's a $3 monthly subscription fee, so plus 3. So it's 25 cents plus $3. Since we're talking money, I'll put 3.00. So there's our equation. 11 says using this linear function, and you use in exercise 10, this one, construct a table to record the total monthly cost in dollars for MP3 downloads of 10 songs, 20 songs, all the way up to 100. Okay, so we're going to need a title, number of songs, number of songs, and total monthly cost. In dollars. Okay, total monthly cost in dollars. Okay, so they want us to start out at 10 songs, and then go to 20, and then keep going, multiples of 10, until we get to 100. And there it is. Using this equation, plug 25 in for X. 10 times 25 cents is $2.50. 250 plus 3 is $5.50. Plug in 20. 20 times 25 is $5. $5 plus $3 is $8. Okay, so these are increasing by 10. So now I have a pattern. Rather than substituting values in and calculating, all I'm doing is adding $2.50 every time. So 8 plus 250 is 1050. 1050 plus 250 is $13. 13 plus 250 is $15.50. 1550 plus 250 is $18, and so on and so on. 2050, 23, 2550, and $28 for 100 songs. 12 says to plot the 10 data points in the table on the coordinate plane. Let the x-axis represent the number of songs downloaded and the y-axis total monthly cost in dollars. Okay, so here's a table. So we have the x-axis, number of songs, y-axis, total monthly cost in dollars. Always label your axes. This should be a y, this should be x, and then substitute in your values. So I'm going to start out with number of songs 10, $5.50. So 10 is here, here's 5, so a little bit higher than 5 is $5.50. 20, $8 is maybe right about here. 30, $10 and just a little bit more, maybe right here. Okay, and I'm going to draw the line now to show you what's going to happen there. I'll just use my ruler to guide me because it's difficult without a grid. Okay, so there's the first 3 points. And so they all should land along this line. So I'm just going to use this as a guide, like I said. So now we're at 40. And 40 is $13. So if I went straight up from 40, 13 should be right about there, between 10 and 15. 50 is $15.50, just a smidgen over 15. So I would say maybe right about here. Maybe a little higher. I might be off a little bit with my points here. So let's reline this up. This one might be a little bit higher here. And like I said, this is just a little bit difficult without a grid. But once I get this straight, then we'll see what's going on. Okay, so now those appear to be about on the line, and that looks like $15.50. So 16 or 60 should be 18, which is just under 20, so that should be right about there. 70 should be $20.50, so straight up from 70 is just over the 20 mark, right there. 80 is just straight up 23. 90, $25.50, and 100 should be 28. So that is what the dot should look like, okay? And it appears to be linear, obviously, and it would continue down so that there is a monthly fee. If you don't buy any songs, it will cost you $3. Okay, next question says a band will be paid a flat fee for playing a concert. Additionally, the band will receive a fixed amount for every ticket sold. If 40 tickets are sold, the band will make $200. If 70 tickets are sold, the band will make $260. Determine the rate of change. Okay, so remember that rate of change is C or M, and that's an equation y minus y2 minus y1 divided by x2 minus x1. So we have two y values. So what is y and what is x? If 40 tickets are sold, the band will be paid $200. 40 is my x. Paid will be my y. If 70 tickets are sold, 260 will be, so this is my x2, and this is my y2, and this is my x1, and this is my y1. So if I take y2, 260, y2, 260 minus y1, 200, and divide by my x2 of 70 minus my x1 of 40, then I get 60 over 30, which equals 2. So the rate of change is $2 per ticket. Okay, so by the way, if I mark that 40, 20, and that's x1 and that is y1, I am really naming a point, 40, comma, 200. And the other point was x was 70, y was 260. So that's where those came from. And then now number 14 says, let x represent the number of tickets sold, y represent the amount the band will be paid in dollars. Construct a linear function to represent the relationship between the number of tickets sold and the amount the band will be paid. So that means come up with an equation y equals mx plus b. Now we just found the slope, or the rate of change, the constant rate of change of $2. So that is my m. So that is m equals 2. So that will replace this m. So I have y equals 2x plus b. I don't know what the b is, but I do know that I have 2 points here where one is x and that's y, and that's x and that's y. And we have x's and y's here, so how about we just plug in one of these two? I'll use the smaller one because it's easier to work with zeros than it is this. So I'll make y 200. Y is 200 equals 2 times the x, which is 40, plus b. So now that I've substituted in a y, an x, and the m, the only thing I don't know is b. And in algebra, we can solve for one unknown. So 200 equals 80 plus b. And then when I subtract 80 from both sides, I get 120 equals b. So therefore, the equation now is y equals 2x plus $120. $2 per ticket plus a flat rate of 120 bucks is what the band is getting paid. So then I just answered the next question. What is the flat fee the band will be paid for playing the concert regardless of number of tickets sold? And that is my b, which is equal to $200. The flat rate is your y-intercept or your b. How much will the band receive for each ticket sold? That is our m, and it's $2. Okay, that is the end of lesson 1 from module 6. Review the lesson summary and go to your problem set.